everybody. Good morning, good afternoon, whichever one it is. Your bell ringers are here on the board, and if you didn't get the memo on the screen, I would like you to do them, or on the board, I'd like you to do them on a whiteboard today. We're going to have a little bit of whiteboard review. All right? So please pause the video and work through the bell ringers. Okay, so for number one, which is not a zero of the function, you can spend time doing an XY chart if you wanted to, and just kind of powering through all the numbers, -3 to +3. But there's an easier way to do it, because you got four options to figure out which one is not a zero. So your method of choice should be just plugging these numbers in and see what you get. So remember, the best thing you want to do with negatives is put them in parentheses when you plug them in. And let's do that here. So we got the first one is to the third power, so the first x is to the third power, second x is to the second power. And then we have minus 10x plus 24. And you get a 0 for the first one. So that's out. Well, this could be a question similar to what's on the ACT. Your best bet is just to kind of plug these in and see what you get. All right, so your next number, if you wanted to keep the negatives just to make it nice in the calculator, you can go to the -2 just to give it a shot and see what you get. And that gives you 24. So -2 is the one that we're not going to have a 0 for that, because we get a 24, okay? So if you did the 2 and the 4, you would also get zeros. And so by process of elimination, a -2 would be your one that is not a 0. Okay, for the second one here, for which parts of its domain does the function have negative values, you're going to have to do an XY chart, okay? And you want to just kind of start with your generic -3, -2, -1, 0, 1, 2, and 3 down at the bottom there. Okay, you're gonna want to do an XY chart, that way we can actually see what values we get for this thing. And when we do that, we should have these values for -3 to +3. So you get a 0, 18, 20, 12, another 0, -10, -12. Okay, so let's kind of figure out what's going on here. We know that this is a third degree polynomial, and it's a positive leading coefficient. So opposite end behavior, so we know it's going to look kind of like this, those sideways S shapes that we've talked about before. All right, so do my numbers in my XY chart reflect that? Well, not really, because this is like the positive area here, which would be comparing it to down here, and it looks like it's going down. So that means we're probably going to have to do some more points in the XY chart. Okay, this one right here would be like my left-hand side, that's the negative values, right? We're at a 0. So we're probably going to have to do some more points in the XY chart for the negatives as well. All right, so you kind of saw that on the homework where you had to do quite a few numbers to get the exact shape. So let's do a -4, see what we get, and let's do a +4, see what we get. -4, that zips way down to a -40. +4 is another 0. All right, so that means we might need to do a 5 to see what happens. If I do a 5, I get a 32. Now we got enough information to see what the graph looks like, okay? It says, for which parts of its domain does the function have negative values? Okay? So I really could, if you wanted me to, I could drag this -440. Let's put that up at the top. So that -440 should go kind of up here with the other negative values. And then that 40 is down here with the other positive values. All right, so now we can actually see where the negative values have. It says for which parts of the domain does it have negative f of x values. So that's negative y values, right? You could graph it if you wanted to, but you can also do it with the chart. So I see negatives from here to here, and I also see negatives here. So that would mean from here backwards, okay? So if we're trying to make this look kind of like a domain and range type thing, my y values, so x is less than 3 would produce negative values, And for here, okay, we're going from 1 to 4. So that would look like this. So 1 is the small number, and then 4 is the bigger number. So between, this is saying between 1 and 4, and left of 3. Okay, so those are the domain values where our graph is negative. And you'd be able to do that with a graph probably a lot easier. Okay, so, but this is just a way to do it with an XY chart. All right, so let's take care of some homework questions and we'll come back to the whiteboards. Make sure you're not sitting there writing notes to each other. Just pay attention on the homework questions so that way you can double check what you did. So I picked a few of them that I thought would be a little bit more difficult, and we'll go through them just to, so you have something to reference. So 26, I thought that might be a little bit more difficult because we didn't do any of those in class, so I'm going to kind of show you just to kind of confirm what you were doing on your homework to make sure you did it right. So we want to sketch a 5th degree function with zeros at -4, -1, and 3. And then we got a maximum at 2. So if we're graphing this, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So let's get our little graph here. If you use graph paper, it probably works well. Zeros are easy. Just put points on the zeros. So we got a 0 at -4 right there, a 0 at -1 right there, and a 0 at 3 right there. A maximum at x equals 2. So what you could do, you could kind of draw like a dashed line, because I know that I'm going to hit a high point somewhere up there. Okay? So let's see if we can draw what we got right now. So 5th degree function, another thing you can kind of think of, since we have that maximum up there, that it's going to be going down through that point. Okay, so let's kind of think of, if we're going down here, that means on the left-hand side, we're going to have to be going up. Okay, so I kind of can draw my function with that information. So I know that it's going to be coming down from here. I don't know how far down it's going. Up, back to here. I know I'm going to hit a maximum here at x equals 2. And then it's going to zip down here. Okay, so right now, we have something that looks like a 3rd degree function. Because remember, yesterday we learned some information about the least degree. So right now, the least degree, what we're showing is that you could have 1, 2 turns plus 1. So that looks like our least degree is a 3rd degree. If we wanted to make this graph look like a 5th degree, we can just add another squiggle on here where it goes back up and then back down. So then we would have 1, 2, 3, 4 plus 1 would be at least a 5th degree function. That's how you would make that look like a 5th degree. And we still have our maximum. We still have our maximum at x equals 2. We have the zeros that were given, but that would be what we need to do. Okay, so there's a lot of information that you have to think of when you're graphing these. So 4, 6, these are the ones that are factoring. They're probably a little bit more difficult for you guys, and we got to them and it seemed like we graphed the concept okay, but then 28 you get to these massive ones, and then it gets a little bit more difficult. So let's do 20 and 22 here quick, and then we'll take care of 28 and we'll explain it. So 20, remember I said you got to figure out what is being cubed here, or if these are perfect cubes. So if I'm looking at this one, 8c cubed, well I know that 2 times 2 times 2 is 8, so the number I'm going to need is a 2, and then it's just going to be a c, because c times c times c is c cubed, and then I have a minus, because we want to just kind of replicate that, and then 27d cubed, so the cube root of 27 is a 3, and then we're going to have a d. So that's the way we're going to begin the pattern. All right, now we have the little set of parentheses here, and then we're going to have the big set of parentheses here, so that way we can figure out what goes in there. So the way I taught the pattern yesterday was we take that front one, you square it, and it goes in the front over here. Take that back one, you square it, and it goes in the back over here. And then the middle here is a combination of the two, where you just multiply the two. All right, so it'd be 2c times 3d, which would give me 6cd. And then to remember the signs, remember it's SOAP. Same, opposite, always positive. So we do same, opposite, always positive. And then you are done. Whatever you have in your parentheses, that is your factored answer. Okay, next one here, 22, you got to see if you can take anything out. Well, I got an a in both of those, so that means I'm going to take probably an a squared out. So let's take an a squared out, and we get a to the 6th minus b to the 6th. So I explained yesterday, once we have exponents that are a little bit more than cubes, then you have to think about what times itself 3 times will get you to a to the 6th or b to the 6th. Well, that would be a squared, because a squared times a squared times a squared is going to be a to the 6th. So when I start my pattern, this would be a squared, this would be b squared, and that's the numbers, those are the variables that we're going to use for our pattern. Okay, so a squared squared, a to the 4th, b squared squared, b to the 4th, and the middle is a combination, so it'll be a squared, b squared, and our signs are going to be same, opposite, always positive, and that is it. You are done. So if you kind of grasp the idea of the patterns here, these are extremely quick. Okay, last one, the big one down here. Grouping. So you got 6 terms. 1, 2, 3, 4, 5, 6. That means we're going to group them in threes. Okay, so you group 3 and 3. So you got to look at it and see right away, if I group it in threes, is there something I can take out in the front 3? Well, you got an a cubed, an a cubed, and an a cubed. So yeah, you got an a cubed you can take out. So let's do that. A cubed comes out, I got x squared minus 16x plus 64. Second half, I got b cubed, b cubed, b cubed. But remember, I have a negative in front, so that means I want to take out a negative b cubed. And remember, when you take out a negative, that flips your signs. So it'd be x squared minus 16x plus 64. And now, do we got the same thing in our parentheses? Sure do. So now that goes in front, that x squared minus 16x plus 64. 64. And then we got a cubed minus b cubed in a second set of parentheses. So then the next thing you want to check. So with grouping, it's a little bit more difficult because you can keep going. Here, you look at the stuff on the left, that x squared minus 16x plus 64. You can factor that. That's a perfect square trinomial. Okay? And then you got a cubed minus b cubed. You can factor that. That's difference of cubes. Okay? So this one factors to x minus 8 squared. Okay? Or you can say, what times itself twice gives me 60? Or what times itself, or what two factors give me 64 and add to 16? That's 8 and 8. Okay? And then the a cubed minus b cubed will be a minus b, a squared plus ab plus b squared. That's just using the cubes pattern that we did twice up above. Now you're done. Okay, so this is more difficult factoring. So if you are done with your homework, please turn that in, and I will grade it later. And once you turn your homework in, take your seats and get your whiteboards back out. We're going to go through a few review problems quick to see what we remember. Okay? So, starting out, let's do these 3. All right, so please pause the video and have students work through these 3 on the whiteboards, and then we will go through them. All right, so on the first one here, we're simplifying polynomials. All right, so remember, you just want to multiply the numbers in front and then multiply the a's and the b's. So negative 4 times 5, negative 20. A cubed times a to the 4th, b to the 5th times b to the 3rd, b to the 8th. You just add those exponents when you're multiplying. All right, for the second one here, We want to graph and identify important points for the function and state domain and range. All right, so we needed to get all of our x, y values. So remember, we go from -3 to +3. And then we see if that's enough information. So -3 is a -4, -2 is a 0, then we got -2, -4, 0, 16, and 50. Okay, so we know that this is a third degree function, and it's a leading coefficient that's positive, so we know they kind of look like this. All right, they're the sideways S's. And so we see if we got enough information there if we need more points for our XY chart. So as we're looking to the right here, numbers are going up, just like it looks like we should on our graph. If we look to the left here, numbers are going down because we're getting a negative number. So we're good there. So we don't really need any more XY values for our chart. So let's see if we can kind of identify what's going on here. So as we look at our Y values, we want to figure out maximums and minimums, okay? So right here, we're negative, and then we're going up to a 0, and then back down to a -2, okay? So if we went up to the 0 and back down to a -2, then that -2 0 has got to be a maximum, okay? And let's see if we can keep going here. So we're down at -2 here again, down to -4, and back up to a 0. So we went down to the -4 and back up to a 0. So that means that's got to be a minimum at 0, -4. Okay, and then if we keep going here, looking here, we're going up, 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 up. That's the right-hand side, so we just continue going up. So we only have 2 maximums and minimums, okay, or 2 turning points, rather. And then we need to identify zeros. So we actually have 2 clean zeros here. All right, so I got one. Let's move this ink out of the way. I got 2 exact zeros when I do my XY chart here. So remember, whenever you get a 0 in the Y value, that would be where it crosses the X-axis. So we got a 0 at -2, 0, and then we also have a 0 at 1, 0. Okay? And I'm not going to graph it. Okay, you can graph it if you did on your whiteboards. Should be fairly simple with the points. But it's going to look something like this, maybe a little bit more curvy. But just know for domain and range that cubics or odd functions are always going to be all real numbers. Okay, so we state it like this. Domain is all real numbers, and range is also going to be all real numbers. All right, and if you're trying to think of domain and range, this function up here, it's going to always open to the left and to the right, and it's always going to continue down and up forever. So that's how we know everything is all real numbers. Last one down here, plugging those in. So we got P of 3 and P of -4. So remember, when we do P of 3, that means I'm just plugging in a 3 wherever I see an X. Just like this. And then you just kind of evaluate the stuff on the right. So 3 squared is 9, and 3 times 3 is 9, so it's 9 minus 9 plus 4, so that means we just get a 4. So P of 3 is 4. P of -4. Here's where you got to be careful, and you got to make sure you use those parentheses. Even in your calculator, make sure you're using parentheses, because if you don't, you're going to have an error. So 4 squared is 16. -4 squared, excuse me, that's 16. -3 times -4 is positive 12 plus 4. So 16 plus 12 is 28 plus 4 is 32. So P of 4, or -4, is 32. All right, hopefully that makes sense. We've done those a handful of times, so they should be fairly simple by now. All right, let's look at the last 2 here, just these 2. So please pause the video and work through those 2, and then we'll come back to it. So bringing back a little bit of binomial expansion, so we're finding the 6th term of that. So there are 2 different ways to do it. So you can use Pascal's triangle, but that would be pretty terrible because we'd have to go down to the 14th row. And that would be a pretty big triangle. All right, so the other way to do it with the combinations. Remember, we had something, choose something, and then we had each of the terms in their own set of parentheses. We had a 2x in there, and then we had a 3y in there, and those all had exponents with them. Okay, so we always start with that. So it's 13, choose something. Well, we have the sixth term, so we always took one less than that. So 13, choose 5. Okay, that 5 is also back here. And then to get this exponent, our exponents have to add to a degree of 13. So we need to have an 8 up there. So let's turn that question mark into an 8. Now we just start evaluating our combinations and our exponents there. All right, so 13 choose 5, gonna give us 1,287. So 1,287. 2 to the 8th is 256. So we'll have 256 x to the 8th, and then 3 to the 5th. I think that's like 243. 243 y to the 5th. So all those coefficients you see there, those constants and coefficients, just the numbers there, multiply them together. So 1287 times 256 times 243 gives us a whopping 80 million. So 80,061,696. I kind of feel like we've done this problem before. We have x to the 8th, y to the 5th. That would be the sixth term of that expansion. So if you were using Pascal's triangle, that would be a pretty massive problem because that's a pretty massive number. All right, last one here, and then we'll get to the new stuff, the lesson. So looking inside here, you always want to start with the inside because of PEMDAS. The x's, so we're going to have a 3 there and a 2 there. Those don't do anything. We got 2 x's on top and 1 on the bottom. So one of those is going to cancel. Got an x left on top. We got 1 y on top, 3 on the bottom. So one of those will cancel, so we'd have 2 down there on the bottom. All right. Now we take into consideration that negative 3 on the outside. So remember when we had negative exponents on a big, like a fraction like this, the first thing you wanted to do is flip the fraction and then cube it. Or flip the fraction and then change that exponent on the outside positive. Now we are cubing. So 2 cubed is 8, 3 cubed is 27, and then remember what you do with the exponents here? You multiply them, so we're going to have y to the 6th, x to the 3rd down there, and you're done. All right, so please put your whiteboards away, get your notes out, and we will start with a few examples of the factoring stuff, and you guys will have some time to work on that in class. Okay, so on to the new stuff here. I guess it's not new, it's just kind of an addition. I'm going to call this something different, okay? So you can call it use substitution. I'm just going to call it advanced factoring. All right, because we're just doing harder factoring here. So starting into it here, we did this yesterday, so methods we know so far. They would be the reverse FOIL, greatest common factor, that stuff. Cubes patterns we know now. This one, there's 4 terms, so that means we know factor by grouping. All right, so let's do this one quick. I'll have you do one on your own. So just to kind of review grouping again. So we got 4 terms up there. We got x cubed plus 5x squared minus 2x minus 10. We split them in half. All right, so we look at the left half and then the right half and see, oops, we missed that 10. We look at the right half there, left half and right half, to see if we can take something out of each individual chunk. So the first part here, we're going to take an x squared out. We have x plus 5. Second half here, remember if you got a negative in front, that's got to come out with the number. So negative 2 is the greatest common factor here, and that switches my signs. Now, do you have the same thing in your parentheses? Yes. So those are your new greatest common factor. So x plus 5 goes in front, and then we have x squared minus 2 left. And then, as you saw in your homework, after you do this, you want to double check to see if you can do anything else. So there aren't any other patterns here that we can do. There aren't any trinomials, so your base methods are out. But x squared minus 2 looks like it could be something, but since 2 is not a perfect square, you can't do anything. So try this next one in your notes. So this one is a cubes pattern probably, just because we got a cube or bigger there, and there's only 2 things. So it's a cubes pattern, so see if you can remember that. Pause the video and have kids work through the example for about a minute or 2. All right, cubes patterns. We got to look at each numbers and figure out what our A and our B are going to be. So 64x is a 6. So what times itself 3 times gets me a 64? That's a 4. What times itself 3 times gets me x to the 6th? That's x squared, right? Because x squared times x squared times x squared, that's x to the 6th. So that's how we can figure that one out. So if that's an x squared here for my pattern, this one's going to be a y squared for my pattern. So it'd be subtracting, and then we apply the rest of the pattern here. Okay, so you got your little set of parentheses and your bigger one that has 3 things in it. 4x squared turns into 16x to the 4th. Y squared turns into y to the 4th on the back end. And then the middle one is those 2 multiplied together. So it'd be a 4x squared y squared. And then we use same. So for the signs, we're going to do same, opposite, always positive, and then you're done here. Not very often can you do something else beyond the cubes pattern here. The only place that you could see something possibly is checking this in front. There might be something left to do there because it could be a difference of squares, which actually, now that I say that, we do have a difference of squares going on. So let's finish that one. Let me get stuff out of the way here. So we got a 4x squared minus y squared. All right, and now that I say that, looking at this, we got to be able to figure out why or when we see difference of squares. Well, this stuff here, they're both perfect squares, and there's a subtraction sign. So that means we have difference of squares pattern. So that's 2x minus y, 2x plus y. That's what the difference of squares turns this into. And then we just rewrite this stuff off to the left here. And now we're done. Sorry for thinking we were done a little bit earlier. Let's try a couple more of those. So, big factoring here. We have 1, 2, 3, 4, 5, 6 terms. All right, so that means we're going to kind of split them down the middle here. Split them down the middle and see if we have anything that we can pull out of the left side and pull out of the right side. So give it a try, see if you can do it. And I'll move this down so we can try that one as well. Okay, so try those 2, and then we will come back to the video. First one, you should see y cubes floating around on the left. And then we got to rewrite what's left. So x squared minus 3x plus 2. Second half, we should see z cubed floating around. So remember, that's a positive z cubed, so you want to write that sign in the middle. And then it's x squared minus 3x plus 2. Now, do we have the same thing in the parentheses? Yes. So let's write that out. And then we're going to have y cubed plus z cubed. And now, you got 2 different things to do. We got the x squared minus 3x plus 2 on the left that we can factor out, and the y cubed plus z cubed on the right to factor out. Okay? So this one, reverse FOIL, 2 numbers that multiply to 2 and add to 3. That's a 2 and a 1, so it's x minus 2, x minus 1. And then this one is the cubes pattern. So y plus z, y squared minus yz plus z squared. Now you're done. That's a big one. Advanced factoring for sure. Okay, bottom one. We'll check that one out. And then I will show you the new things to factor, and then I'll get you your homework. Okay, so cut it in half. Look to see what we can take out. So we can take an a out of the left. We're going to have a plus 3y. And then the right half, we're going to take a positive 2y squared out. And then that will leave us with an a plus 3y. We got the same thing. Yes. This one's a lot easier than the last one because we're going to be done after this. So a plus 3y, that's my greatest common factor. And then we're going to have a plus 2y squared in the second half. And you can't go any further than that because there are no trinomials, no difference of squares, cubes, nothing there. So you're done. Okay? So I'm going to jump way ahead here. We're going to skip the brain break so you have time to do your homework. Okay? And I'm not going to call this U substitution. Okay? We're just going to call it advanced factoring. Because U substitution, we're going to skip that, and it should be easy enough without that word. Okay? So go ahead and write this down. We're going to actually solve these. All right? So we're going to factor and solve. So keyword here, solve. So I'll just write factor and solve. When you factor and then solve, you will have an answer for x. If you factor, you'll just have stuff floating around in parentheses. So this is actually fairly simple if we think of the ways that we factored before. So I know we have a fourth power, but let's just think about doing it like everything we did before. Okay, so what do you think would be in the front of the parentheses in order to get an x to the fourth? Well, we need an x squared and an x squared. That would get me to x to the fourth if I started FOILing this out. Let's just see if we can do it like the old way of factoring. So what two numbers multiply to 100 and add to 29? Might have to think about that a little bit. An easy option for 100 is 10 and 10, but you can add 10 and 10 to get a 29. So let's see, maybe like a 15 and 14. That's too big. Let's say 50 and 2, too big. Let's say 20 and 5, too big. Let's just start dividing hundreds by stuff. So 104. So 100 times 4 gets me, or sorry, not 100 times 4, 25 times 4. So 4 and 25. And the way I get that, you just kind of start taking 100 and you start dividing it by stuff. Divide 100 by 2, see if you get what you get. So that would give you 50. 50 and 2 is not going to give you 29. 3 doesn't go into it. 4 gives you 25. So can you put 4 and 25 together to get 29? Yes. So it doesn't matter where the 4 and the 25 go. They just go in the back of the parentheses. So that's how you factor that. So the 100, yes, it's a larger number, so you're going to have to try more and more options. But we'll try a couple more here when we're done. So then you see if you got more patterns going on. X squared minus 4, x squared minus 25. Do I got more patterns going on? Yeah, I got difference of squares going on in both of them. So I have x minus 2, x plus 2. All right, so if you forgot difference of squares, this is where it comes back pretty heavy. And then we're going to have x minus 5 and x plus 5. And then since we're solving, we have to get answers for each one of these. So remember our zero product property, where you take each one of these and set them equal to 0. If you do that, you're going to get x equals 2, x equals negative 2, x equals 5, x equals negative 5. It's pretty much think opposite whatever is in the parentheses. Okay? So let's try this one. We'll try this one together, then I'll give you guys a couple more to try. So looking at it, we got x to the 6th and x cubed. So the only way you can actually get this to work is if these powers are double each other. So that 3 has to be, so that would have to be a 6 in front. Up here we had a 2 and a 4. If they're not double each other, then you can't do it. Okay, it wouldn't factor out nicely. So let's try to see what we're going to do here. So set up my two parentheses. How am I going to get that x to the 6th? What am I going to put in front? I'm going to have x to the 3rd, x to the 3rd. Okay, so if I multiply those out, that would give me x to the 6th. Then 216, we're going to have to start trying to divide it by things to see what we get. So let's say 216, I know that 6 times 6 times 6 is 216, but that's not going to help us out. Let's take 216 divided by 12, see what happens. 12 and 18, not going to get us there. All right, let's try some more factors. Trying a whole bunch of different combinations, just take 1 times something, like trying to get to 216. 8 and 27 are the actual factors that we need. Because 8 plus 27 is 35. So we're going to have minus 8 minus 27. And I guess another way that you can kind of think about these, and maybe it's just specific to the way the book is set up, is when you get cubes, you know, they're probably going to have you try to do a cubes pattern. So you could have tried to start multiplying cubes like 8 times 8, 8 times 27, which is the ones we have here, 27 and 27, or 64 and 8. All right, those would be options that you could try. Some of those are going to get you pretty big pretty quick, but 8 and 27 are the numbers that we need for the factoring. So it's 2 numbers that multiply to give me 216 and add to give me a negative 35. So I know they're both going to be negative here. Okay? And then we need to keep going because we have cubes patterns going on. So x cubed minus 8 would turn into x minus 2, right? Because we know that x would be my a and 2 would be my b, because 2 times 2 times 2 is 8. And then we're going to have x squared. It's same opposite, so plus 2x plus 4. That's the way the pattern would go there. And now the x cubed minus 27 would be x minus 3. X squared plus 3x plus 9. And then you're done there. So this kind of turns into a cubic, so then it just kind of blows up from there because we have to factor the cubics out. All right, that's the way it goes. Let's see if we want to do a couple more of them here. So let's try to do these two. See if we can figure these out. So this is to the 4th power, just like the one we did here on the top. Okay, so we're doing a 4th power here on both of these. The second one down here, you're going to have to see if you can figure out with SMILE method if we can do it. All right, so see if you can figure these two out. We're solving all the way through. Okay, so on the first one here, we know we can set it up with an x squared in there because those are double each other. So we're going to have x squared, x squared. Now we want 2 numbers that multiply to 30 that add to 11. Okay, multiply to 30 and add to 11. So that would be a 6 and a 5. Okay, last time we factored one of these, or factored and solved rather, we could break it down fairly easily and just get our 2 answers. Now, do you see any other patterns going on here? That's a no. X squared plus 6 is not a difference of squares, and x squared plus 5 is not a difference of squares. So what you got to do is take each piece and set them equal to 0. Just like this. Okay, and then you solve them. We've solved stuff like this before in like chapter 3. So for here, subtract 6, subtract 6. So we're going to have x squared equals negative 6. I should have moved my work. I'm going to move this a little bit. That way we have a little bit more room. Okay, so we got x squared equals a negative 6. Well, how do I get the x squared to turn just into an x? We need to square root both sides. Okay, now the next thing a lot of people forgot was that whenever you square root both sides, you got to put a plus or minus there. Okay, we have x equals plus or minus square root of negative 6, and then you simplify that a little bit more. It's plus or minus I square root 6. So don't forget about imaginary numbers. So that would give me 2 solutions there because the plus or minus gives me 2 things. Second half here, minus 5, so x squared equals negative 5. Square root both sides. Same kind of idea. We're going to get plus or minus I square root 5. Okay, so we got 4 answers. All right, so the plus or minus for each one of those gives us 2, so we got a plus or minus in there twice, so we get 4 answers. The way you can check to know if you have enough answers is you look at the degree of the function. I got a 4th degree here, So that means I'll have 4 answers when I'm done. Unless it's something like you get the same answer twice, like a 2 and a 2 or a 4 and a 4. That would count as 2 answers still. Okay, let's try this one down here. So, can we take something out first? Well, that make it a little bit easier if we take something out. We got a 4, a 10, and a 6. They're all even, so that means we can take a 2 out. So I have 2x to the 4th minus 5x squared plus 3. So that 2, we can kind of get rid of it here. We don't really need it, because if we divided both sides by 2, oops, sorry, there should be a 2 there. We'll just leave it there for the time being. So then in front, if we're trying to break this down, that 2x to the 4th, that means we're going to have a 2x squared in one of them and an x squared in another one. And then you're going to have a 3 and a 1 in the back end. We just need to figure out where. Okay, if we're looking to get a -5, that means we're probably going to have a -6, which means the 3 goes here, and then the 1 goes there, minus plus. So remember, when you check it by multiplying the outside and then the inside, and then you add those together and see if that gets you your middle number, which it does. Okay, so this is the correct factoring, but we are doing more than that. We're factoring and solving. So we said each of those pieces equal to 0, if we can't factor it anymore, which we can't. Okay, set each piece equal to 0, and then solve them. All right, so the top one here, minus 1, 2x squared equals to -1, divide by 2, then we're going to have a -1/2 over there. So x squared equals to -1/2. Square root both sides, and this one's going to be kind of, you got to remember how to rationalize here, because remember when we square root these, you square root the top, which would just be a 1, and then you square root the bottom, which would be a square root of 2. So this is going to be 1 over square root 2, but don't forget we have that I in there, and I'll move it to the other side in a minute. So this is going to turn into, so you have to rationalize like that. So it turned into square root of 2 over 2. Have the I there, and it's a plus or minus because when you square root both sides. So you just have to remember how to rationalize. So when you have that square root on the bottom, you take it times itself. Second one, add 3. So x squared equals 3, square root both sides. X equals plus or minus square root of 3. So double checking here in the end, how many answers do we got? That's going to give me 2 answers. That's going to give me 2 answers, which would give me 4 total. So I have a 4th power polynomial, so I have enough answers to be done. Okay, so there is your homework assignment. If it's something about quadratic form, which it could be in there, just skip it or try to factor it, okay? If it says quadratic form, try to factor it and solve it. If it's not solvable, then write prime, okay? So good luck on that. Let me know if you got any questions, and we'll see you later.